Okay, good morning. So today I will present an overview of some of the tools that can be used for building liquid wallets. I will, as I mentioned yesterday, we will not deal with like all the node consensus and federation stuff. We'll use Liquid as like people that are using wallets. Just like when you use a Bootcamp wallet, you don't really care and know how the mining procedure is happening, how the block is formed. You just want that your transaction will be part of the block sooner or later. So we'll put ourselves in this perspective, which if you think about a lot of products, is most of the time the only thing that you need. That will simplify things. Of course, the consensus part, the federation part is important, but it might not be important from a practical perspective to actually build something. It's just important in terms of like the security and it's implied. This is today's program. So we'll start with an overview of the wallet tools, the various components that might interest you to build the application that you want to build or the tooling. And then we do a hands-on demo using LWK, which is among the tools that we'll present during the first session. We'll use a CLI tool, which is written in Rust and can be installed with a simple Carbon install LWK CLI. But we'll also use the web interface, which is LWK as well, just the WebAssembly findings. And we'll use both of the two. Both of them, we'll use them with Jade, because LWK has also support to talk with the Jade and provide it with the information that is required to sign transaction, and of course before to fetch the extended public keys that of the key that are signing with the Jade. We also see the Python build, which is a very easy to use way of getting to interact with the Liquid blockchain and to create a Liquid wallet. And we see how all of those things are intercovered. During the first afternoon session, we'll talk about Liquid swaps, and Liquid swaps in the sense of swap within the Liquid network. Liquid has multiple assets, and we can leverage that to build transaction that has different assets in input, and these different assets might not belong to the same person. So basically, we can do a transaction that atomically exchange some asset for some other, which solves the problem that in traditional finance is often called settlement versus delivery. So basically, instead of waiting for a payment to appear, it simply happens at the very side. I will also try to leave a bit of room for some question because we will be dealing with a lot of different topics, and if you're interested in some of them in particular, you can deepen more into those, and I will try to leave a significant amount of time for that at the end of the afternoon or the first afternoon. So let's start. Let's start with the context of like this very first presentation. We'll start with some wallet concepts. I'll assume that most of you has some kind of exposure to like Bitcoin wallet concept. So like backends, like signers, and how do you exchange transaction, these kind of things. We'll deepen more into the Liquid ones. So how Liquid is different, where are the difficulties in Liquid, and how Liquid can be used to like, how we can leverage like this Liquid, not be like held back by those. So then we will see a created list of wallets, like wallets that user can use. Those wallets are kind of the distinction between like the various components is not always clean in all those wallets, and we'll try to understand better like what is doing what, and so that you can better have a better view of like which tooling might fit your use case. Then we'll see the low-level libraries that are used to build those wallets, but can be used to build other products. We see the possible backends that are the blockchain data source. So basically where you fetch your UTXOs from. And we'll evaluate the different trade-offs between them. Some of them might be more reliable. Some of them might require more resources. Some of them might have issues in terms of privacy. Then we'll see the SDKs, so the software development kit, which are like higher level libraries, which should help more like wallet or like hub developer to build an application that has a liquid wallet. Then we see signers, which is basically the entity responsible to actually sign transaction. And we'll see the possibility that are currently available right now. We also go through the supported languages. We have a wide variety of supported languages, which might help you to integrate the software that we built or that other people built in your projects. Then we see a piece of infrastructure that is used to share information about an asset, which is the asset registry. We see how it works. It's confusing sometimes, so we'll try to demystify that. And also we give a very brief introduction to simplicity in order for you to understand its capabilities and how you can use it right now. So for what concerns the wallet concept, we start with the confidential transaction descriptors. Then we'll understand how the blinding works, and on both sides. So the first side, how do you blind a transaction? And then on the other side, that is the receiver side, how do you unblind the transaction? Then we will see the different blinding standards that are currently available, and we'll have a view of what are partially signed elements transaction and the PSN. So let's start with this CT descriptor. A CT descriptor is a very simple, obvious extension of the descriptor that are the output descriptor that I use in Bitcoin. I hope most of you have some kind of familiarity with. So basically, an output descriptor describes the script up key that you can derive for a wallet. Basically, the set of these script up keys identify the wallet. For Liquid, you need a bit more. We need the script key alongside with the corresponding blinding statement. And to do so, we simply need to extend the format. So we'll have the Bitcoin descriptor and a descriptor blinding key, sometimes referred as master blinding key, which, however, it's somehow confusing, so we opted for a different terminology. So the Bitcoin descriptor is actually a bit more than the Bitcoin descriptor. It has a prefix just so that it doesn't get confused, and it has support for more opcodes because Elements is more expressive than Bitcoin. It's defining the ELIP 150. The ELIP repo, it's growing, and it contains a lot of information about the standards that we want people to use, and that should facilitate interoperability among liquid wallets. So with a CT descriptor, I'm able to derive an address, which however is not confidential, meaning that it does not have the blind public key. With a CT descriptor, I'm able to derive a confidential address. So the script up key plus the blind and public key. However, some of the descriptor, I want to put more information in that. So not only the blind and public key, but also the blind and private key, so that I can later unblind that output. That is necessary, for instance, if you want only access to a liquid wallet, because you want to see which are your outputs, but you also want to be able to unblind. You want to see this output as like 1 BTC and this output as 100 USDT. So if you with this standard, we can encode that in a standard way, a way to share the private blinding keys of of a descriptor of a wallet. This simplifies a lot the infrastructure that is needed to build wallets. So basically, we don't need to query another wallet for private binding keys, or we can simply have this string, which give up a little bit of privacy because, like, the entity that will have this private descriptor binding key will be able to combine, but it's useful. Let's say that I want to set up a service that is processing incoming payment. Then with a descriptor binding key, with a confidential descriptor, with a private descriptor binding key, I can do that very easy. Without that, it's extremely complicated. So this standard allows you to build things in a better and streamlined. So we've talked about blinding, and blinding is a not so easy concept. I often give it as you understand it. I want to reiterate a bit about the whole process. So a transaction can be a confidential, like we see on the left side, with all the inputs and the output being known by the observer, or it could be confidential. So it could be when it is explicit, everyone can see that. But normally, the standard way of doing it is that you will have all the output and input confidential, so no one will be able to see that. Technically, this happens by blinding the output. And so basically, instead of having an explicit asset and an explicit amount, we will have a commitment for those values, plus other fields that are needed to allow the sender and the receiver to actually know which are the amount involved in the transaction. So basically, the process of blinding starts with the receiver. The receiver generates confidential address. This confidential address consists in a script key, which it derives from the Bitcoin descriptor side of the CT descriptor, and a blending key pair, so a private blending key and a public blending key, which was derived by the descriptor blending key side of the CT descriptor. Then the sender creates an explicit transaction. So in the flow is that it starts to create the transaction with all the output in an explicit fashion. And then for each output, it blinds the transaction. Blinding the transaction consists in basically encrypting the data that the receiver needs to know in the range. Here I'm providing all the details. I'm not going through that, but if you are willing to get more details, I can do that later on. And also you have the slides so that you can do that even in the next days if you prefer. So basically you are encrypting the unblinded values, which are the asset, the value, and the blinders in the range proof. And then later you will need to, the receiver will need to unblind them. So basically it will fetch a transaction, which will be unblinded, and which will be recognized that is owned by the receiver, since it has the receiver's script key. The receiver will regenerate the share secret, which was used to encrypt the data, and then you will decrypt the information that is needed to understand what he just got, and of course it's necessary to spend. So to create a blinding key, there are different standards, and so the first one is LEAP 77, which is for legacy keys, and is the most adopted right now. However, it suffered few problems, and for that reason, a new one was added, which was defined in the LEAP 150. And there is also a deterministic way of doing it, which has some pros and some cons, which is LEAP 151. This area for context, those are not really do not really matter. Each of them has their own trade-off, but all of them are available, and right now we are kind of in a position to try to migrate away from LEAP 77 However, it's not super easy. Just to mitigate a bit confusion, CF77 also define a way to derive the master blending key for from a mnemonic, which is somehow orthogonal to what we are defined by EM. And then EV150 also define the standard for CT transaction, which is again somehow orthogonal. So the scope of those two improvement proposal is slightly wider with respect to the blending key standard that we are defining on this slide. The next wallet concept that I want to go through is PSCTs. PSCTs are SPT for liquid, basically. So you need some kind of format to transfer information for like various entities to sign transactions. And in Bitcoin, we do that with PSPT. With Liquid, we have PSCTs, which are basically PSPTs with a bunch of more fields. These fields are the one involved in binding and the one that are around like issuance and like the addition of new fields or assets, basically. The definition of those is on the media wiki on Elements, but also some of the definition you can find that on the documentation of Rust Elements, which is often more updated. The standard is not completely set in stone. It's evolving. Constructing the fact that we have binding in Liquid makes like the whole procedure extremely more complicated. The SPTs also like started with like these roles, but like these roles are not strictly followed by all implementation, and often SPT is just a standard to transfer like data. People are not really following what this is doing on the like role side. On Liquid, this is even more complicated, so do not expect that. Yet, it's important to have a format that is useful for sharing information among different entities so that we don't need to invent our own standard. We just have a way to get information going from like a watch-only wallet to a SACTA. Now we go through the existing user-facing wallets. We have LWK and Elements CLI, and sometimes it's as Elements Core, which you saw yesterday, James. And this is also Elements Qt, which I did not mention here. And that is like the wallet implementation that is tied to the node. It's written in C++, and but you can access them through the LPC with a number of different languages. Being that tied to the like node implementation, which is in some sense related to consensus, it's quite hard to customize that, and also quite hard to use that like in a wallet framework. So while it's good for some sense, for other use case, it might not be the best tool. Then we have Blockstream Green, which is this one. And Blockstream Green has support for a different variety of like backends. It can connect to the Blockstream Green server, which enforces 2FA if you are willing to, and it support for AMP. It also can connect to Electrum servers, and it does so for its single sig implementation. Inside, it's based on GDK, which is an SDK that we'll see in details later on. Then we have Sideswap. Sideswap has support for the defaults to single sig and using an Electrum backend, but it also can connect to the Blockstream Green backend for A and B assets. Then we have Aqua. Aqua has support for a limited number of assets. This is a UX choice by the Aqua team. So you can only move LBTC and USDT. I mean, you can receive all of the asset, but the they will not be shown in the UI, which is not ideal, but in terms of UX is a choice that has some reasons. Apple is also is integrated with a lot of different services to swap, but they are kind of out of scope with respect to the presentation of today. Then we have Bitcoin, where Bitcoin is very similar to Aqua in terms of how it works, but it doesn't have support for USDT. Then we have Marina, which is a web wallet based on Liquid.js, and not particularly familiar with it, and but you can use that in your browser. Then we have LWK CLI, which is a command line tool that is based on the LWK library, Bernice, and it's a fully fledged wallet, and it can be used to do a wide variety of things. And during the next session, we will see some of those. We also have Liquid Web Wallet.org, which is a web wallet based on LWK, which allows you to leverage some of the feature of LWK from a web page, including connecting a JADE and use that as a sign-up while you fetch information from server within the browser. I want to stress out that this website was only developed by engineers, and that's why its UX is like very engineer focused, and it had no help from the design team, and you will perceive that. So now that we've seen like all these wallets have like very huge stacks. Like you need to get some kind of place where you get information, and then you need some kind of places where the information is stored locally so that you can and you have a decent experience. You want to display that in a nice way, and then you want to sign. To decide how to do that, you need to make a lot of UX and product choice, those engineering choices. Now I want to like give an overview about like the components that you will be dealing with if you are going to do something with a Liquid wallet. So we will start with like the low-level libraries, which kind of share among like all the different components, but are like stick and stones. If you want to build a wallet, probably you want to start with something that is higher level. Otherwise, everybody will need to continue with each of. We will see the backends, which are like the possible blockchain data sources. I mean, when you receive a transaction, you want to be aware of that, and you need to fetch it. There are different ways to fetch it, and those depends on like your setup. If you are building like a mobile application, you want some kind of server to get the information from. If you are building like a server application, perhaps you want the like different degree of performance, and you don't really care about like privacy or this kind of things. Then we will see the available SDKs, so the software development kit that are out there, which are basically higher level libraries. So if I want to build a wallet, perhaps I don't want to code how to connect to a specific server, handle that connection, and so on. Those SDK are there for that reason. They kind of solve some common problem that Liquid wallet have. Finally, we'll see signers. So how do you get the transaction signed? You try to keep that logic separate because the signing part is the delicate part. Since our Liquid, just very similarly to how we do that in Bitcoin. The asset that you are owning, those are bare assets. So basically, if you mismanage the key, then the asset is lost. You want to keep that part separate, and so that developers can do their choice whether to be like to do things in a more user-friendly but risky way, or to do things in a way that is perhaps foolproof, and but it puts some kind of friction, so that maybe you need to use another wallet, or need to move the PSCT to a separate device to get it signed, and so on. So these are the low-level libraries that are available. So the first one is the zero-knowledge group version of SIGP, and that's easy inside the other libraries. And then we have liboli. Liboli is a set of utilities functions for Bitcoin and Liquid wallets. It's written in C, and it has an interface that is focused on performance. That means that it's very nice to use that in Jade, since it allows us to build Jade in a way that is performant, despite the hardware, which is very does not have a lot of computing capabilities. But on the other hand, if you're using that like on your laptop to do some kind of scripts, it might feel a bit hard to use. Then we have two Rust libraries, which are Rust Elements and Elements Miniscript, which are a bit higher level. And being those in Rust, I have a slightly easier way to be approached. And then we have Liquid.js, which is not developed by Blockstream, but it's a library that can be used to manipulate Liquid transaction on the JS stack. There are more libraries that are involved in building a wallet. For instance, if you want to connect to an Electro server, then you need some kind of library that will handle all that complexity that you want to forward yourself every time. But of course, here we are just mentioning the ones that are Liquid related. On the backend side, so basically when you have a transaction, when a transaction that affects your wallet is propagated to the network, you want to be aware of that. So you need, for when you have a wallet, you need a way to fetch the data that affects your wallet. And there are different ways to do so. Here I'm making the ones that are ready to use right now. So the first one is Elements D, which of course is behind each of those. And with Elements D, you can fetch information about your wallet, but it lacks a key feature. Just like Bitcoin D, it lacks an address index, basically. So it's hard for you to get information about a random wallet. Either you load the wallet in advance and you let the node monitor it, or its interface is a bit difficult to use for some generic purpose use case. Then there is Green Backend. Green Backend, it's not open source, but it's available to use through GDK, and that is a possible source of blockchain data. Then we have Electros. It has two interfaces. One is the Electrum interface, which is like a standard Electrum interface that you can interact with, and which is used by most people out there. And it also has an HTTP interface, which is we call it the Explorer interface, which can be used in other circumstances. Is useful. Finally, we have Waterfalls, which is like an extension of the Explorer interface. And instead of asking the server each script, like you do in Electrum and in Explorer, you simply share with the server the part of your confidential transaction descriptor. So you share the Bitcoin side of your confidential transaction descriptor. So instead of doing 20 or more calls per each descriptor, you will just do one call to the server, and then the server will provide you with the list of transactions that affect your wallet, of transaction IDs that affect your wallet. That's worse in terms of privacy with respect to the Explorer and Electrum approach, which are equivalent, but in terms of performance, it's better. So it's kind of a trade-off. And also in Liquid, this is very similar to the controversial approach of sharing an extended public key with the server, which some people really do not like. But on the Liquid side is slightly better because the server cannot unblind our transaction. So if they know that I'm interested in those transactions specifically, that might be okay because they don't know if those are LBTC, are USDT, or some like worthless asset. So in this sense, on the Liquid side, it makes more sense. And it was kind of also necessary for us to build some of our for all of this, you have like some of the resources in the link that I shared in the group. Then we go for SDKs. So SDKs are libraries, but a bit more cooked. So basically, you don't have to do everything from scratch. They do a lot of the things for you. These are some pros and some cons, because sometimes you want to do things slightly different, and the SDK do not allow it. And that might have a good reason, like it might be something that it's dangerous for you, and that's why we are not allowing you to do that. But some other times you should be allowed to do so. And so you have this kind of trade-off. We have two SDKs. The first one is GDK, which we'll describe soon after. And then we have the LWK, which is a bit more recent. So GDK is the SDK behind the Green apps, basically. It has Liquid and Bitcoin support, contrary to LWK, which only has Liquid support. And it's the only way to interact with the Green backend. Technically, it's not, but practically it is. We do not advise you to do that with like custom connections. It doesn't really make much sense. And since AME requires you to interact with the Green backend, it's the only way to use AMP right now. With the second version of AMP, that will no longer be necessary. It will not be another restriction anymore. It uses the Green backend for multisig, but for single sig wallet, it uses Electrum servers. The code base is written in C++ and Rust. It's based on like Diboli and other libraries, and it's quite hard to extend. The approach is very monolithical in a sense. So if you want to do something slightly different, it might be very hard for you. Just perhaps you want to fork the SDK and just tweak it a little bit for your use case. That's something that completely understandable. With GDK, it's quite hard to do. It has bindings for Python and JavaScript, which are used in the mobile apps. Then we have LWK, which was built later. So it had an advantage, which was we kind of learned from like the thing that went wrong with GDK, and it has a more modeling approach. So just to provide an example, there are different crates. Here we're listing a few of them. So there is a crate, which is the main one, which is the wallet crate with the O that is not a spelling mistake. It means is a watch only wallet. So it does not sign, basically. And with this wallet, this crate is responsible for like getting the descriptor from like the user and to get the transactions that are related to that descriptor. After those transactions are obtained, then it will display like your balance and will display your UTXOs, and it will allow you to create transactions. So basically you can specify, I want to send this amount to this address, and it will create a transaction, blind it, and once the transaction is ready, that can be passed to a signer. We have another crate, which is responsible for handling like the software signer and the hardware signer. So basically we want to have the same interface, which is we give to the signer a PSCT. And basically the signer with the PSCT and the descriptor, then is able to understand which is like the net balance of that transaction with respect to that wallet, which is identified by the descriptor. So basically, on my signing application or on my Jade, what I would see is, okay, I'm sending this amount, this address, and I can also see like, this is the net balance. So like the change out, I can understand which are the change outputs, and I can only display like a user from like a application developer perspective, which is like which funds are going out and which funds are staying within the wallet. Then we have a crate, which is a dependency of the sign-up crate, which is responsible to like handle all the Jade specific complexity. To name a few, like the Jade needs to be unlocked with a procedure that involves the remote server that is storing the decryption key for the seed in the Jade. Doing so, it's doable but it's kind of complex, and we want to handle that complexity once. So basically, with these crates and all the logic for you to securely connect to this remote server, to transfer the information that the Jade has given you, and then to transfer back whatever the server has responded, and to handle all like the possible failing case, like the pin is wrong, like the connection dropped, and so on. Also, Jade interface on the Liquid Sign is quite complicated. It doesn't accept a PSCT. It accepts another format. PSCT will come at a later stage, but we don't care. On our side, we did all the complexity. So basically, you pass a PSCT to the interface that we define, and internally, we do all the work to convert it to what Jade expects. So this is kind of the approach of LWK, to try to pick all the complexity that is liquid specific, Jade specific, and so on. And when you use LWK, we want you to deal with that. We want you to deal with like the specific things that you plan to do, that default thing, that default value that you want to provide via your application. So, as I was mentioning, it has been built-in hardware support. Right now, only Jade. In the future, Azure 12, that's in the works. Hopefully soon it should be available. And also, by leveraging the CT descriptor, the descriptor in general, we have support for generic multisig. So for instance, you can do a 3 or 5, perhaps with a combination of Jades and software signers. And you can handle all kinds of transactions through LWK. So perhaps you can do issuance, reissuance, and burn. Those are not available. Those and the generic multisig that is not available in GDK. We also add WebAssembly bindings, so we can make like the whole crate web friendly. So basically, you can use LWK within the browser to build the application that run to that. The code base is written in Rust, which allow us to have a quite fast and secure development cycle. And there are bindings for Python, C, Kotlin, Swift, C#, WebAssembly, React Native, and nothing more. Perhaps something else that I'm not remembering. And the bindings are not perfect because it's just two of us working on LWK, and we are not experts in all these languages. Our idea is that we put out a binding that work, and then if someone is using those, then they can improve them, and we can have some kind of collaboration. For instance, this happened with the Board Bitcoin team, which and they were using the Dart Flutter library for their mobile application, and that's the missing binding over there. And basically, they did the bindings themselves in their own crate, and right now they're kind of helping us in that sense. To provide another example of like how LWK provides value, um, if you want to extend it, you can do it in a fairly easy way. Also, you don't need to affect all crates. You might affect only a single one. Perhaps you want to do something that we might port upstream, or perhaps that will not be the case. We try to accommodate both use cases by having like a code base that it's easy to boot your hands on. In terms of like the state of that code base, it's relatively new. So perhaps in terms of performance is not that where we would like that to be, but we will, as soon as we will find some time to work on those to-dos and fix space, we will improve that in an incremental way. Also, LWK as a CLI tool, which is a way to showcase its capabilities, that is basically a fully fledged one. It allows you to sign KCTs, to do issues, to do reissues, to create multi-sig wallet, and also do things such as publishing stuff to the asset registry. We will see that in the next section. So speaking of signer, I already introduced them during like the LWK crate introduction. So possible signer are software signer, which are basically like a mnemonic, an extended private key, or RB32 seed. And those are the ones that are more handy. Most apps use them, but are the ones that are like more unsecured. And especially if you are developing apps that runs in the browser, it's something that you perhaps want to avoid, or at least discourage in some sense. And then we have the two hardware signers, which are J, Ledger, which is in the work and should come in the next months, I guess. We will see in the next demo how to use the software signer and Jade with the CLI tool, and also with the web interface. Yeah. So this is the better list of supporting languages. Not all the libraries support all the languages, but if you have some kind of expertise in with any of those, there is something that might fit your use case. So in terms of like the things that have a lower entry barrier, probably is Python. We have wheels built for eBold, for GDK, and for LWK. So you can just pip install them, and just play with them. GDK and LWK use like light clients. So basically, you don't need to sync and load to use them. They use the client. I mean, they use the Bootcamp servers for actually basically the Electrum servers, which in terms of privacy is not ideal, but it's convenient, especially if you're working on a prototype. Now, I will talk briefly about the asset registry. So when you issue an asset, the asset, as you saw, has it's identified by a 32-byte string, and it's in terms of like if you're a computer, that's a good identifier, but if you are a person, it's not. So basically, you can associate. You saw it yesterday. Some kind of extra information to that, and you do that at the issue phase. So basically, you decide a name, a ticker, a domain of the issuer, and you commit that to the issuance. And by doing so, basically, you commit that to the asset ID itself. And so we have this process to register this metadata to a repo that we control. So basically the issuer will choose this contract, so the name, the ticker, and the domain, and other information, and it will commit that to the issuance. then it will upload to it to a domain that it controls, a link that says basically that I run this domain. I want to connect with this asset, and then the issuer provides this information to the asset registry. The asset registry verifies like the commitment and the domain proof, and if that goes through, then it stores that in like a huge JSON of all these contracts. And when wallets then can fetch information about a specific asset, so that in my UI I can display that this asset ID correspond to this sticker, for instance. We will see that how to do that in LWK, and yeah.
Maybe you're going to show this later, but I just had a question. How does it commit to this contract? So this contract is a JSON object, and how does the issuance transaction commit?
So the precise answer is in the code. So basically, you have this contract. You serialize that following a proper standard that is defined. We have different examples, and you serialize that, and then you hash it, so that is not explicitly in the transaction, and then it's serialized within the issuance field. And this issuance field, they are hashed again, and the result is the asset ID. I was not extremely precise, but I think I got the flow. So basically, what happens when a wallet fetches like this contract is they repeat this hashing procedure and verify that, for instance, my Leo token is commits to my asset ID. So basically, I cannot change it afterwards. I cannot change name afterwards. So this is the flow for the asset registry. This is something that these is how things work right now. Perhaps in the future they will change. Some people were suggesting that we should put this kind of information in an explicit way within the transaction. There are different trade-offs in terms of that. For these kind of things, what emerges like the consensus about like the people-equal assets. So that's how things are doing right now. I'm not saying that I'm endorsing this procedure. We are almost at the end of this session, and we are talking about simplicity. Simplicity is a smart contract language which aims to outperform Bitcoin script and like other scripting language for blockchains out there, and outperform it in terms of both trustworthiness, but also in terms of safety assurances. So since very few days, since the end of October, it's available on Liquid Testnet, so you can play with it. And we also offer like a more development-friendly language, which is called Symfony, to write simplicity program. Simplicity is super cool, but differently with respect to what we have seen before, it's something that will need a bit of time to build product on top of it, when the rest of the things that I displayed are more down to earth. If you want to build something that can go to production in like a couple of months, then probably you want to build on like simpler tech. Simplicity is like top of the big dash. But soon it will be able to Liquid Mainnet as well. So it's something that you definitely want to keep an eye on. Next, so we'll probably do a quick break, and next we'll see how to use the LWK CLI, which is fairly easy to install, and we'll be using also the Liquid Web Wallet tutorial, so that we can see how a possible way of integrating this LWK library into our web stack. And we would be also using Jade and with both the tools. And then we'll see the Python widget just to see a glimpse of like how that can be interoperable with both of the things. So, by the way, it could be a nice tool to do like some small project to get your hand dirty with these kind of things with a very, very small setup phase, because you simply connect. You will be connecting to the Electrum server that is publicly available, so it will simply work. So that was it. I think we'll have a 10 minutes break, I don't know many, and then we start. It's not a it could be what's supposed to receive and have personas. So I'll start in the second part of the demo, and I hope you can see well. So we go through as I mentioned before, that LWK CLI, and then we go through the liquid web wallet, which is this one, which I hope you can see nicely, and then we'll also see the Python way, so that you can kind of have a grasp of like what it's capable of, and like also the state, which might means that there is room for like some PR, some cleaning stuff, and so on like that. So we start from installing the CLI. So we can install it with install and LWK CLI, or if you want to fetch it from trace.io, but we can also install it from source if we git on the repo. I'm the one releasing the app, so I trust Trace.io. And I will be using Jade too, so I will add a feature which is not on by default, which is the serial feature, so that my LWK CLI will communicate with the serial to get information from into the Jade. So we'll just do it. It's very fast because I just did it. Otherwise, it takes quite a bit. And also the feature, the serial feature might have some problem on different platforms. If you are on Linux, it should be fine. But if you are on Mac, maybe skip the serial feature and just use software signer. These kind of things are improved, but they take time, they take iteration, and especially if as developers to tap that specific machine, it's not really a priority for us. And so we start with first checking the health. So we have this is a command line interface, and it has basically 4 entry points. It has a schema endpoint which provides you the JSON in case you want to interact with the CLI in a different way where you start to the one that we're using right now. So basically, you have server commands which are used to set up a local JSON RPC server, which is basically responsible for doing a very small thing, but quite nice in terms of user interface. So with then it's been some thread in the background that sync the wallet, so you don't have to call the sync automatically, which is something that instead, if you're using the crate, you would probably want to do, because if you're building an app, you want to control when it syncs, when it adds information to the proper backend that you chose. Because what might happen is that this communication might not be successful, and you want to handle that probably the UI, or perhaps you want that to happen only at specific events. Perhaps the user is dragging some screens down or entering through some page. And also, you want to perhaps present some kind of information when the sync is completed. And for that reason, we do not mandate like the CQ mechanism at an SDK level. But for this CLI, it would have been the best route, and that's why I needed to spin up a server local. The idea is that the server is local, you just spin it up and then you talk with it from another terminal. Then we have the signer commands. The signer command are needed to interact with signers. We can load signer and unload signer, and we will see an example for those. And then we have the wallet commands, which drop the ban with the stake pool. So we call that wallets, but internally those are both-only wallets. Finally, we have the asset commands. Yes, commands are needed to, like when you issue an asset, you want to store some information within the CLI. And so and then we have some kind of utilities to build the contract and so on. We have then the network option, and the default is testnet because we are in the early days, but you can use that with main and direct test as well. So let's start with spinning up the server. So the default is testnet, so I'm not specifying the network, but I could do something like that. That would be exactly the same. I will just show you like a couple of logs. The logs are there. They're not created very much. We should tune them a little better so that you expect something like less in debug. Right now, if you tune debug on, it logs too much. It's not to be stored anymore. But for instance, you can see the configuration file now. You can see that the network is testnet, and you can see that it has some default values. The default values are like the data directory, but more interestingly are the URLs which the LWK CLI will connect to, which is the box script for endpoint for the Electrum server, and then there is the Explorer URL, because we will have the possibility to get the transaction list. The transaction list will have the fully unblinded URL, which is quite useful. And then we have also the Explorer API for some other interaction with this library. We have a scanning interval, meaning that at each 10 seconds that takes to update the state, and that can be cured. Also, we have an asset registry, which is the default one for it tested. Yes. Go back to stored. So let's see the apps for the wallet commands. So we have a bunch of them. Okay. So we can load and unload a wallet. A wallet is identified by a financial transaction descriptor. And additionally to that, we give it a name so that we have a effect with the sign when calling it through the API. Then we can unload it, meaning that we simply is forgetting about that. And then we can do a few possible fixes to physically create transaction. So we can first get an address, which is necessary for you to get some funds in it, and get the balance with which will use the asset IDs or the names if we have the name available, and that's why we have the asset interface. Then we have a simple send, a drain, which is like a send all. Then we can issue, reissue, and burn. All this operation will not actually be action, but we create a PSET, so an unsigned transaction that does the action. After that PSET is created, what we need to do is to pass that to a signer, and the signer can then actually send the transaction so that we can broadcast it to. Then we have other utilities, so we can get the utility source, the transaction, we can set a variable that was required by the irresponsive, which is using LWK alternative, which provides LWK as an alternative to element score if you do not want to have a fully synced elements node. Then we have some operation that you can do for PSETs. So basically, let's say that a signer has just given you back a PSET. You want to understand whether the signer has actually signed the PSET. That's something that you want to do in the CLI, and if you're building any application, you want to do that as well. Perhaps you don't want to display that to the user, but it's still a middle way to understand that this basically is more designed more often. And we also have a way to get a multi-sig descriptor, and we'll see that later on. So let's now do the flow to create a single sig descriptor with a software wallet, which is like the simplest way of doing so. To create a single sig, we need to start from a signer. So we need to generate a signer and then derive the single sig wallet from that. So let's see the signer out. So we have a bunch. We have a generate command, which is used to generate the software signer. And then we have some specific command for J, which are JDE and LWK, which we'll do later. And then a software command to load the software signer that we will use later on. Then we have a command to sign, which is like the key command in the signer interface. And then we have a command to get the sender to my key, which is used for instance Bootcamp. And the command to get the single sig descriptor, something that we definitely need to go through to get it. Of course, the single sig descriptor comes out of the signer because it's basically just it. It does not need some kind of coordination on maintenance. When what is it one? It's one. We also see a register multi-sig command because if you are using a J, you need to load the multi-sig descriptor basically into J. So that the J can show the UI that you want to register on the J, that multi-sig descriptor, so that it doesn't. It does recognize the tree output as something that belongs to the J. Otherwise, it will display you the J output as something that goes elsewhere. So the CLI approach is a bit broad in some sense, but I think that for like if you plan to build an app, it's important to get exposure to like all the nasty things that you will need to somehow hide or stress in the UI. So I think it's while let's say the web part is nicer, the CLI allows you to better deal with every step. So let's start with generating a software wallet. So here is the software wallet, which is a spelled word mnemonic, which I'm just doing in my clipboard, and then we will load the we load this mnemonic, this software signer. So we'll specify the mnemonic, and we will explicitly specify if we want to persist the signer. That's like another application's way of doing things. Since it's a mnemonic and you are persisting that unencrypted, we want you to say it's into the CLI. That's something that we as developer that are building like tools to manage real funds want to do, so that people, if they get burned, we can say told down. And that's it. So go. Then I think it had the name, which calling software, and then persist, which is correct. So we got the name. It was successful, and the fingerprint. The fingerprint is like a way to recognize the signer, something that is you might see in a descriptor on the key origin part, and that we will see later on. So we can also, now that the signer is loaded, we can see that, and also we can get the details. The details include like the fingerprint and the extended version of the fingerprint, which is sometimes useful, and that's why it's there. The mnemonic in plain text, which is not nice, but it's useful sometimes. And yeah, it's in plain text to persistent on my computer, so it makes sense to expose it. The name, the type, and the extended public key is the master extended public key. So, what to now get to like to the descriptor, and to do so we have like 2 ways. The first way is to get an XPath and construct the descriptor from that. The extended public key command block requires you to specify a kind. We do not allow you to specify any kind of derivation path. We do so because some derivation path, you should not really be using that, and on the CLI we can tend to restrict these kind of things. Of course, if you're using like the crates, you can get any kind of derivation path, and if you do a very simple modification to the LWK code base, you can get the whatever path you want. If the path you are interested to has some kind of meaning, you just submit a BR and we'll back it. So we may get that for B49, which, if I remember correctly, is the one for rapid sec width, and that's the key origin and the XPath. Why we export these instead of just the extended public key? Mainly because that's information that we want to fit into the descriptor. It's information that allows like a signer to understand where the extended public key is coming from. So the extended public key is what we actually use on the wallet side. While the information in the brackets, it's the fingerprint, which can be used to identify the signer. So basically, if the signer is a software signer, I can just use that instead of attending to the derivation and then mentioning the extended public key. The fingerprint, of course, might have, it's short, so it might have like it's an identifier, but it's not an identifier. You might have a single fingerprint and multiple signers associated to it, but that's the likely, and in practice will probably not happen. Anyway, the code internally handles it, and that's among the things that the LWK side we want to do. And when you check the CLI code, you can use that as a reference. Perhaps if you have given up to some of the issue that might arise, we might have already covered that, or we might have not. But at least you kind of get a usage of LWK which should cover most of the pinpoints that you would face with using like the library website. So after the fingerprint, you have the path. So the path up the last hardnet derivation step is 39, then 1 because we're testing it, and then 0 because we asked for the first account. Of course, we can wrap that into a key descriptor, which would be quite simple in this case, but since it's very simple, we can simply automatize this. And so we have this single sig descriptor code, which we specified the signer. So in this case, we specified our software signing, and then we specified the distributed binding key. We have different ways of specifying it. We do that we choose IP77, but that's not the only choice. Other could be there, and although those are the only 3 options, there are more. However, when we expose stuff from the CLI, it takes time for us, and unless we get a specific request, some of the things might get into that later on. For what concerns the kinds, we only have 2 kinds available, which are the 7-hash and the wrap 7-hash. In theory, it will be possible to use also the public key hash version, but using that in Liquid does not make any sense. although it's possible and allowed by the consensus rules, it's something that you should definitely not do. Because when you are dealing with he said with stuff, then the transaction ID might change, and some protocols might not accept the transaction which have intents which are pre-signed. So don't use that, because there is no good reason to do that, and there are good reasons to avoid it. So let's create the descriptor. Course, I will choose zip77, and there is no specific reason for that. There are different trade-offs. zip77, it's nice because it's fully compatible with JT, while the other ones are not. And and that's the main reason why that we will probably be used with our Excel. However, it's sometimes zip77 defines a way to derive a master binding key, a descriptor binding key, according from the mnemonic, which for Simple-Sig is obvious, but for multi-sig it's not, because there are multiple mnemonics and you might not have them available to be. You probably have at most one of them available. So there are other versions, which is like the random version, in which like the zip77 key is a simple is a random key, not derived determinacy from anything. The other version that we have here available is ED431, which is basically a way to derive the descriptor binding key from the descriptor itself from using another piece. So here's the descriptor. We have to collect it. So let's analyze it though. Field 4. So we see the descriptor, and we see that it's wrapped in a SYN key bracket. So big one. And then we will have the first part, which I will uncomment, which is the descriptor binding key, which basically is saying I'm following the zip77 standard with this specific value. And after that, there is like the Bitcoin descriptor, which is prefixed with is EL. And then there is a descriptor that in this case is fully compatible with the Bitcoin descriptor, because it's a very simple one. So it's a witness public key hash with the key origin information, that is this one, which consists in the fingerprint, and the derivation path up to the master hardware step. Then we have the extended public key, which it's not an expand because we already tested it's a debug, but it's the same. And then we have the last two derivation steps, which are the ones that are not alternate. So we don't need to derive the extended public key after those. And it's the first one, it's wordle buffer. So 0 for the external chain and 1 for the internal chain. That is the thing. Yeah. Finally, we have a wildcard. The wildcard means that you will derive different addresses for that. You will start with 0, 1, 2, and so on. It's important that when you derive new addresses, you do that incrementally so that the syncing procedure can happen without you searching for like a gazillion number of addresses. So you simply perform sample, because then when you restore a wallet in any kind of setup, then it works in like seamless. At the end here, we have the checksum, which is just used to make sure that you haven't changed something in advance. Okay. Because, for instance, if you change like just a single byte or bit of the ZM77 key, then the confidential address that you generated are different. If those are different, then you're not able to apply that if you don't have the correct ZM77 key. So there are trade-offs in this sense, and the checksum entry there, but also like using standard that might not be, it depends on how you transfer these kind of things. So perhaps if you want to derive lib77 in a deterministic way, that might help you. But if you want to use lib 151, I have you. So now we have the descriptor. We go on the wallet side and we have to load the wallet. So we need to specify the wallet name, which we call it symbol 6, and then we specify the descriptor. Wait. So okay. So it's in the descriptor and it's providing you with the name. So let's go and check the details. I need to specify the wallet, and I'm saying to it since. So it's saying to me the type, which is the public key hash, and says no warning. Sometimes and we want to issue some warning, so we have a field for that. And then there is the list of the signers bond, so that when I go for wallets, I know that I will need to query the signer which has name SW and as is pickable. Of course, the name is something that is only bounded to like these instances of the server, while the fingerprint is bounded more defined. Let's receive some funds.
I have a question there. You say that the name is binded to the server, is to the twin server, right? So the LWK.
Yeah, it's binded. I mean, it's binded to my local instance. It's something that I just use so that I don't have to specify like the descriptor every time. I just want a short name that it's handy for me to iterate on that, but it's something that is just local for me. It's something that will not be interoperable with your instance. Let's say that on your instance, you have the same wallet descriptor, same city descriptor. You can use a different name and all occurs.
And on the SDK, you have to handle that, or you also have what is a name for?
I mean, on the SDK side, on the LWK, on the CLI side, the name has a meaning. On the wallet side, there is no meaning for the name. On the wallet side, you just have the city descriptor, basically. So it's just an entity for that. So we want to get the address, and we want to specify the wallet first, and which is symbol 6, and that the index is not necessary. If you don't specify the index, it will provide you with if you don't specify the index, basically it will provide you with the last unused address, and which in this case is address 0. Then you have other options, like you can specify the signer. That's necessary for instance if you're running a jade, for using a jade, and you want to confirm the address of the jade itself. We'll see later. And also you have the possibility to encode the address in QR format, which is a utility that is quite useful in some specific use cases. In this use case, we use just a utility that it's available to my system. If someone wants to send me some funds, otherwise I will do it myself. So we send some funds to my Blockstream Green wallet. See, I mean, okay. Yes, yeah. Good. And always send 0.1 LBTs. So, well, can just the balance. This is the option. Obviously, it's very well. So we see that you have still some funds, and you see the transaction and explore and so on. Of course, the CLI is making you think about fakes. So if you display them, it just display the LBTC curve. Spot a bit more as an X trick, which is it's your machine. If the CLI is operated by a machine, that's the default you want, because it's better. X strings are better than the names, yeah. And the CLI, it's for also for that kind of use. If you want to use that, for instance, will be like features open, and you want to deal with it programmatically. You don't want to have the default being like LBDC. But in this case, it's not nice at all. So I would specify the additional flag, and I will have it with its asset. Of course, LBTC is special. We know already that that asset ID corresponds to LBTC, so we don't have to fetch that asset ID from specific places. So we have seen the balance. We can see our UTXOs now. There is mass intensity of those. And yeah. Okay. These are our UTXOs. For the
With second time you enters the with tickers comment, your funds suddenly added, I don't know what at my one just to without the tickers to the check-in again. Yeah.
Yeah. Some of it. Now it makes sense. So we received the UTXO from my box agree and Falcon. That with it. And so again here, things we've not added with tickers here. So with tickers, we have to add in there so that we forgot. But it's something that is doable. So you have the information about like the UTXOs. We don't expose everything because of course you have more information. We have the blind and so on. That information is available internally, but of course on the CLI we expose like smaller value. So we have seen UTXOs, and we can also see transactions. So the transaction is with tickers. So when transaction will be a bit more verbose, so just deal that. So first transaction, which is I think it was mine. This is the net balance of the transaction, which is positive 0.1 LBTC. All the amounts that displayed in the CLI are in Satoshi because we don't want to deal with like the madness of precision, decimals, and so on. I think that's completely crazy. And even though we might expose some kind of utils to convert like to decimal format, ending those from like a developer's perspective makes no sense at all. And then we have some details about the transaction. We have the timestamp, we have the I, the Z that was paid, the type, which is very simple because it's coming. And then we have the underlined URL, which is the URL, as you can see, like I will try to use the URL for transaction on Liquid Testnet. Then we have the transaction ID, which matches the one above. So I do to deny. And then we have these extra fields, which are given to the to our Explorer to unblind the transaction in the browser. If we can delete, if we keep opening this. And we got the transaction and a lot of my private stuff, but now it cares. And so the transaction here is with the link. If we copy that without with the embedded information, if we copy that without the embedded information, it's like that. So you see nothing here. If you add that extra data, which basically we can parse it because here it's only one. It's very simple. It's the amount, it's Satoshi. Then we have the asset ID, and then we have the asset blending factor or value blending factor. I don't remember the order, but the coding's there for us to remember. And but here is made automatically, and throughout of the whole LWK stuff is made automatically. Of course, we are only able to apply one output here, only the output that I received. I really don't know how many amounts we know. Was the amount here, which was the amount here. Since the fee is paid in LBTC and there is a single output, I can infer the asset of the output of the with certainty. So the input is for sure LBTC. And since the input is for sure LBTC and there is no issuance attached to that, because I can see that by inspecting the transaction, no from there, then I know that all the outputs, all the assets in input and output are LBTC. Wait, this kind of orthogram, but it explains you which kind of information you will buy them. If there were two inputs, then it could be any asset. I mean, of course, you know that one of the asset in the input will be LBTC because the key has to be based on.
I never, the input is for the confidential where there is more than one output because you don't have like one input and one output and I can see the input.
So basically, so I can, let's go, which is the information that this transaction provides. So if we can see, I mean, you can actually see right here, but I mean, by inspecting the transaction, you can prove that there is no issuance. And you know that one of the output, which is explicit, it's the fee one. The fee one must be explicit because, I mean, it must be something worth it. If I'm only transferring a worthless asset, then the fee is not a scrap dash. So the fees is in LBTC. And thus, some of the input must be in LBTC. Since there is only one input, that the is LBTC. But then, if all the input are LBTC, then all the output are LBTC. And so, for this specific transaction, the information that you get is that all inputs and all outputs for the confidential are LBTC with this deduction process. You, although do not know the amounts, even in this case, where you know that the amount is of one output is 0.1 LBTC, and the fee is like a few Satoshi, you know that the information that I get is that the amount in either is greater than the 0.1 BTC plus 200 and at least 5 Satoshi. That's the only information that I get. And yeah, so let's go back. So we can see the next transaction. The next transaction is kind of the same. It's the one that called me by surprise. And it has a very similar information with it. Let's yeah, we can also see the list of wallets. How we have only one. And check if I forgot any command. So, nope, you got all of them. I think maybe details I haven't shown me. No, I think I should. So we got some details. And the main detail, when we look at the wallet, is the signer. Because, I mean, I want to understand what when I should sign. Something that you might forgot. And, like, it's something that automatically you want to do in your application. So now we want to build a transaction. So the possibility are, so we can send, we can send all assets, which is slightly different. And I mean, if you're using LWK, you will kind of understand the difference between them. And then we can issue the and burn some assets. We just do a send transaction and we'll send to ourselves or to any of you. It's you're giving me an address in the chat the next 1 minute. So let's see the output plus send, which will be quite complex because. So you can specify the wallet, and then we will be able to specify a recipient. And the recipient can be specified in that format, which is a bit active because so that you can specify multiple recipients. And if instead of sending an address to an address or to BUR, so send to an unexpectable script, you can just type BUR instead of the address. And if you want to send LBTC, just skip the STB. And you can specify a fee rate, and you can enable the CT discount. This discount is a way to, it's an improvement to the liquid cloud policy where basically blinded transaction will cost the same with respect to a blinded transaction, which was kind of a bump that we had for the second demo. We'll ignore it. It's just a different way of estimating the fee, but it's not really relevant. So let's see if someone else sent me an address. Copy the pistol. I will send the post, but in 2 transactions. So LWK CLI, wallet, send. I will specify the wallet, which is single C, and then I will specify the recipient. And the recipient will start with the address, and then the Satoshi. I will send you, let's see, this amount of Satoshi, and I will send you a BTC, so worthless us. Very nice. Let's do some networks, which is easier. So we got a PSCT, which is you. That's the only field. I think it's the only field that is there. Yeah. Okay. So we put that in the variables. Trying to reflect that was the syntax. Okay. Okay, that's the case. So we created a PSE and we stored that in a variable. Before doing more, let's see the details of that PSE. Details is for the wallet details. PSCT details is for the actual details. So we can specify the wallet, can specify the PSCT, and we'll show it with figures. It's so the details are quite small. So we can see the net balance of the transaction. We saw that we wanted to send 20,000 Satoshi, but the balance here is negative 20,000 Satoshi and more because we are counting also for the fee in the end. That's what is matter. And then we have a field which is a signature from, and there are no signature because this is fully unsigned. And then we have a field with like the missing signatures, and we're missing a signature from this signer. We have also fields for issuances and reissuances. That's not the case for this BSCT. But in the future, we will see how those will be populated. And that can be reflected in the UI, of course. So next step is to get this BSCT signed by the signer. So let's go to the signer. Of course, the signer is on another machine. And we will. And in this on this side, we expect like the wallet side to be available as well on the signer side, so that it can get the details on his side too. And but it's not exposing the signer interface on this side. But if you were building a signer application that was just signing, you probably want to expose the signing details also on the signer side. Of course, getting the details of a PSCT means a lot, and it's you must try to get some kind of agreement on what that should mean. I mean, what it should check. I think the most important thing is the then balance, but there are some that might apply, and you definitely want to check for those. You want to make sure that the value in the PSCT are semi-standard, and we need to find the right trade-off on the LWK side so that we allow and for people to do some kind of things, but also we kind of provide a safety belt so people could not be attacked by people maliciously injecting like data in a PSCT, so that the signer then signs something that it is not supposed to sign. So let's sign that PSCT. So we just need to specify the signer name, which is software, and the PSCT. Again, it's sign the PSP, which it's huge. We will call it sign PSCT. And we will get the details for it. Yes. Okay. So I got actually basically not the JSON out of the JSON, and that's the new beast. So what has changed is that the has signatures from now is filled with like the signature from the software signer, while the missing signature are empty right now. So next step is we can broadcast. So we can we pass the wallet, and then we pass the key, which is the signed key, and then issue is say dry run, so that it would just do a kind of test member accept. So that's the case, but I mean, we want to actually broadcast the transaction, and that's the transaction. Let's check for it in the Block Explorer. Terrible practice, but so if you check the transaction in the Block Explorer, it says everything is confidential, but let's look for it on this. On our side, so that's the transaction. And as we can see, there is like more outblinding information, because we have outblinding information about each inputs, which are 2, and 1 output, because we don't have the outblinding information about the output that we sent. So this is the outblinding information. We are able to unblind all the output, but like the sent output is unblinded only through difference, which is not so nice. But yeah, it's a nice way of exposing that in the UI. So that's the flow for single sig and for the software wallet. I long overdue in terms of time, so I will continue later in the afternoon, and I will do a discussion with a software signer, the software signer that we created, and then treat, and then we'll see that also on the webpage. Would you mind really like going back to the man where he said you get the sign and listen to this? Or this was the plan. So it's the same. Basically, you can always do BSC details. Of course, when you do BSC details, you want to specify a wallet because you want the net balance of that BSC with respect to that specific wallet. Because I mean, if I'm going to sign it, if I'm displaying the UX for that wallet, I want to understand what that BSC is doing if it's going to be broadcast. So that's kind of the BSC details is kind of necessary because we are passing around this insight or this transaction that might need to be signed by different parties. They want to understand what it is doing and who needs to sign and who has signed already.
You can see also the details for a BSC that is outside.
Yeah, that's of course. So this one is the sign ones. So we can see both the same time. Okay. So the upper one is the signed one and the lower one is the unsigned one. Later we can see something more complicated because when we will have like a multi-sig, we will have like different fingerprints that I pulled different names, and that's kind of the flow with multi-sig. Multi-sig is a powerful tool, but from like a UX perspective, it's hard to make it like testable for users. The security improvement that it allows are quite nice, but maybe if you think about like the normal users of our apps, but they might not be enthusiastic about dealing with like this kind of flows. But yet we should engineer things so that they can leverage this kind of things. But that for some setups, it's the best tool. You should make it accessible. So I think we should break up for lunch. If you have any questions, this is to come to me during lunch and afterwards. And later at the afternoon, I will continue with the multi-sig demo. And the second important, and if you have any reference, just ask me so I can calculate based on your requests. Again, after the day, I always do a quick presentation about the swaps. So the swaps that are only on the LWK chain, and how those are building blocks in different steps and in different protocols, and how those can be a building block for our products set. So that was it. Thanks. Well,
Probably.
it means
Yeah.
so. What it is? It's
That's
very longer. So this afternoon, this is my last session, and this afternoon we'll continue with the demo, which took far longer than I expected. And the demo will consist in showcasing a bit the interoperability of LWK and the standards that we have. And to do so, we will use the liquidwebwallet.org website, which is using the WebAssembly bindings, and we will use that to create a multi-sig wallet with a Jake. Then we will try to send to that address with the CLI, a new asset that we will issue from the CLI. That's kind of the plan. afterward, we will have a very quick sneak peek of the Python way, which is the most accessible way to play with LWK and to do like very small project with it. And afterward, we will go very fast through like liquid swaps, the swaps within the liquid chain. So let's start. So I'm on this website, which is Liquid Wallet. You can check the GitHub source code, and it's basically a very simple website. And the idea is that we wanted a place to showcase how the WebAssembly bindings work. So the website is engineering design, so it's not nice at all, and the UX is terrible. But I mean, it's not the point of the website at this stage. So first step, so our first consideration is that like for JS stuff and web stuff, we really do not want to handle private material in the browser. In general, we try to discourage that as much as we could. That's not a rule of thumb, but it's something that we try to obtain. And there is the possibility to create a random wallet with a random mnemonic, but just because we are in testnet, if I win at that, will not be possible. So let's start and connect with the Jade. So now on my Jade, which is not mine, it's a courtesy of the Spencer team because I forgot by, and I'm asking to unlock the Jade. So basically, it started the whole pin unlock process, and I need to insert the very secure pin that I have in front of us, which is federal offset. And I just did it, and now it connected with the remote server, and it decrypted locally the seed. So basically, everything happened through the browser, and just text to the Jade crate, which is then wrapped in the signer crate, which is then wrapped in the WebAssembly crate. We can unlock it, that easy way. That the UX is very useful. That's easy. I mean, the graphics are terrible, but like the flow are very what you expect. So right now we want to create a multi-sig, so we skip the select part where we can create a single sig. We want to create a multi-sig. So we want to do a 2 of 2. And first key, we do the Jade one. Now, so Jade is asking me to export the master writing key because it's configured to do that by default. So the first one is the Jade key. So this is the Jade fingerprint, and this is 87, which is the let's say the derivation path for multisig. There are different multisig standards, which was Pixar, which seemed the most appropriate. And then there is like the other element of the bar, and then the XPub. Want to add another XPub? We will add the one from the CLI. So LWK CLI, signer, XPub, the name of the signer, the software signer, and the kind, which we will use BIP87, the same one, the one from British. I will copy that and just paste. Boom. Seems correct. The fingerprint are oddly, they seem quite the same, but they are not. So we have a 2 of 2 right now. And we have the wallet. The wallet is just a descriptor, and it's here. It's fairly simple. CT is 77, and this is the default stuff since we're dealing with Jade, saying settings, what you want. And then is a witness script dash, multisig, 2 of 2. I mean, you trust me, there are 2 keep just only put. And the keys are very similar to the one that we saw before. One, we call it multi, and then we want to register it from the Jade because so that the Jade will recognize the output test. Okay, I'm asked to register multisig, name multi-type, 2 of 2, sorted no, the blending key, which, I'm not checking actually. The fingerprint of the first signer, the derivation at the next part, that part which is empty, that the second signer, which is the one for the software wallet, and then I'm asked to confirm. Confirm. Done. So now we have created this multi-sig, and we want to go back. Now I have to close it. I want to get virtual access. This is very engineer-like. I know where the flows are. From a UX perspective, this might sound confusing, and I would use this virtual descriptor. Cool. The balance, of course, is 0. I just created the wallet, and let's get an address because we want to find it too. I want to show the address, but I'm using a Jade, so yeah, it's not as we did the Jade because it's not single sig, but yeah, that's probably available through the CLI, but we have a few typical swings. So we have this address. We're going to send something to this address, but let's do the second step. So we want to do an issuance. The issue does not have to come from the multisig, but we want that to go to multisig. So the multisig will order the asset that we issue. So let's issue the asset from the CLI because we have some funds there. So we have some funds, and so we can bid on the issues. So, yeah. Let's check the command. So we need to specify the wallet, that's the Satoshi that we want to issue, the address that we want to issue to, the Satoshi token, the Satoshi of the ration token that we want to reissue, and the address of the ration token. Of course, the address of the ration token is not mandatory, and the first one is not mandatory as well. If it's not specified, it's issued directly to the wallet. And then we can specify a contract, which is the one that you've been dealing with yesterday, which is the one that is you want to register on the registry. So let's create a contract. We have an intuit that allows to do that. Let's check it. The domain, we use a placeholder, a domain that always verifies. That we specify an issue key. We specify a dummy one, which I am here. Yep, named onboard. Okay. They want to specify the precision. We will go with the false 0 teratheter. The theta will be the hook. And a name. Forgot. This will be the name they're going for. Okay, cool. That should be it. So we got the asset contract specified, and this is like the JSON that we should pass to the issue command. Let's send. Sure. So let's go with the issue command. So we need to specify the wallet. Then we need to specify which is symbol C. Then we need to specify the Satoshi of the asset. We will issue them. Then we need to specify the Satoshi, the Satoshi of the token, which will be 0. We don't want the asset to be issuable. And then we want to specify the address of the asset, which will be the multi-sig one. Okay, and then we'll specify the contract, which very often do not work because of formatting stuff. Hopefully it does, otherwise we'll skip the contract. So let's do the issuance. It worked. So that's a PSET. the usual mess. Let's pipe the queue affair. You have a touchpad, lock keys key, and then let's put it in a basic device. So we want to get the details. The details we will get that in the same way. I've overwritten the basic variable that was before. Okay, so these are the details. We see the balance. The balance is just paying out the fees because that's going out of the wallet. And that there is a list of issuances. The list of issuances contains the gains of the issuance. So the asset, the Satoshi issued, the fact that it's not confidential, and some other details which are useful. And then specify that it's not, the KC key is not signed. We need to sign it. To sign it, we do that just as we did before. And so we use the very same command. LWK, CLI, signer, sign, we specify the software wallet, and then the KCP, which now is different. So let's go with it, and let's check the signers. So it's the very same as before, but it now has signature from the signer. So we can broadcast it. When we KCLI, I think it's the same as before. So just copy paste. So LWK CLI, then wallet, then broadcast, and then we specify the number of the name of the wallet, and then the PSP to broadcast. We just broadcasted the transaction, so the asset has been issued. Let's check the balance here, and hopefully it will see something received. So we have received this asset. Now we'll just spend it so that we can see how amortization spend is done. We go really fast on that. First, we'll send some money, some work on this address. Receive. Okay. Okay, I will do it with my phone. We're doing this letter with the LWK CLI wallet. Send. I will send 2000 Satoshi of LBTs. Okay, cool. I will send the transaction, and we'll broadcast it. Okay, I messed up with something. So let's start again. So it's in here. Yeah, let me can. So yeah, so this sending. Let's sign it. So this should be signing. Okay. Let's get the details. Slowing into a broadcast. Send. Snellen. Something is wrong with this transaction. So for the sake of the deal, let me then send with my mobile. There we investigate what I did wrong.
Or there's a possible test.
Yeah, I could, but the faucet is always under attack by the helpers trying. So I will use. Yeah, the faucet is an option, and Okay. Bounds. Okay.
I just said things on the first
Okay, thanks very much. Let's see the balance. We got some funds. Let's do a transaction, and let's send one of the assets to the LWK. We'll let the Civil 6 signer. So let's get an address. Got the address. And or to create a PSC. Here is the address. Here is the value. We'll send just one, and the asset is the one that we just issued, that we haven't registered on the registry. That's why it has this weird string. We could have, but the procedure is a bit, it's not that nice. If we have some time, we'll do it later. So let's create it. Add it. Okay, we have this PSP. Let's analyze it. So it's already there. So it's basically the same information that we saw before. This is the net balance. So it's spending 70 Satoshi for the fees, sending one of the assets, and the fees are exactly the test will be this internal means bound. It misses two signatures, one from 7838 and the other from 7838. So we can sign this, to sign this up, this PSCT. So let's first sign it with copy PSCT, and then we want to sign it with our signer, since it's one of the two that is required to sign. So to get the details, to get the details, we need to load the descriptor from that side. So I'm not going to do it right now, because if you get the details for another world, what will happen is that the net balance for that will be something that you cannot recognize, and also to not be able to combine some of the stuff that the BST is not blinded. So we would sign the MPSET, the multi-ST that we had signed. So we sign with the software signer, and then we specify the PSET, which is MPSET. Okay, we got the PSET. Let's pass the JSON. Signed more details. Okay, now we just want to we have it. I just want to copy it. I just didn't which is not nice, but it works. Okay, so I pasted the new PSE that I just signed, and what changes with respect to before is that it now has a signature from the software signer. which is 78E8. 78E8, and it misses a signature from the jade. So I want to now sign it with the jade. So this is not the place where to do so. I will. Maybe I'm not clear enough since I do not understand how to. So this is not the way to do so. Okay, here I'm with the J. So let me go back, do that from scratch. That's this pin there. Let's connect it in with the J. Okay. So now I have to select a wallet. Since previously we registered the wallet of the Jade, now we have an additional option, the multi-sig option, which basically then was got from the Jade. So basically the Jade, it asks the Jade, list me all the registered multi-sig, and then now they are available. So now we have this additional option that by default should not be there. It's just there because previously we registered the wallet. So we selected, and now we have this the balance for it. I want to sign the BSC. Okay, now it does it. The reason before previously it was not working is that this page was connected with the Jade, while the other one was. So I paste the PST, which is not the perfect one. Apologies. So let me grab the correct one. Start here. Okay. Okay, so now I managed. Let me go to this is space here. Okay, so it's missing a signature from the Jade. We want to sign in with the Jade. Let's sign it. Check the transaction with the Jade. It took a bit, and the Jade was locked out. So let's do it again. Connect to the Jade. Serve the twin. Okay, got in PSET. I don't know if it's the right one. It's not. Okay, that's the right one. Let's sign it. So basically, I think this firmware is not compatible with the Jade, unfortunately. And we have this version, and this PSPT is making the Jade crash for some reason, which is a bit unfortunate, but it will not work. That's like live demo has had this kind of issue, so it might happen. So let's try again to do something slightly different with respect to that. Let's say if multisig doesn't work. then I need to work out why this hasn't worked. So let's go back. Let's connect in the jade. Let's get the pin. Let's create a single sig wallet with the jade, which should be able to spend. We need to just confirm it has some funds, and let's try to spend them. So we create a BST, and we paste the address to remember which it was. Too late, and I will send just 1,000 Satoshi of testing BTC. Add, create a BST, not enough funds, send less. The remote. Okay, so we create the BCK. Is sufficient funds. Why? Put us some balance. Okay, let's try it again. Stunned. So I don't know why, but we can do it in another way. To have a transaction signed with the J, we connect that through LWK. So we do this quite fast. So we want to get the JDD. Want to get the JDD. Now he's asking me to unlock the jade. Just did it, and now it provide me this value. Now I want to load the jade as a signer, and it asks me to provide the name of the signer, which will be jade, the ID, which is the one that I just got, and then it will simply work. It actually, the last step did not ask nothing to the jade. I want to see the signer and want to get the details of the jade. These are the details of the signer. So the type is a jade, basically. And now we're going to create a single sig wallet with it. So it's a single sig descriptor. And then we want a descriptor blended key. We want 677. We don't really care. And the coin is with this number here. And this side is jade, of course. It's asking me to export the master blended key, which is what I did. And then I got the descriptor. So once I got the descriptor, I just create a new wallet, which is so load, and the name will be signer J, and the descriptor will be this one. Okay. So I want to get an address for that. I want to get the balance first. For this wallet, which is signer Jake. Balance is 0. I want to get an address. I will send some fund to that.
But you are using J, those are not the same keys that you were using to the web. I mean, you shouldn't have the same balance, but you have to.
Yes, that was my guess, and that was I was checking the balance, but there is something wrong with the LWK wallet website, and it's receiving a lot of updates. So recently, so sometimes we break things, and also we don't have like the bandwidth to test everything. So sometimes we are kind of keen on adding new feature, but also when we mess up things. Okay. So let's then send some funds there.